Hi guys. Okay, I have had my coffee and I am ready to record this lesson for you. We are beginning lesson 22, so this will be section 1 of that lesson, and it starts on page 461. 461. This is the family letter for the lesson, so it just kind of explains what you're going to be working on for the next few days. I think this is a 5-session lesson, so there's going to be probably 5 videos for this lesson. It is all about adding and subtracting fractions still, but with line plots. So line plots are something you learned in 3rd grade. They look like this. It looks like a number line, but it has X's. Okay. So this should be review from 3rd grade. You should at least recognize these. But if we read just this little beginning part of the family letter, it'll help us understand those a little bit better if we don't remember them. So it says a line plot is a way to organize a group of data, such as a set of measurements. A line plot gives a visual view of the data. The line plot below shows the lengths of different pieces of yarn. Each X represents a piece of yarn. Since there are 9 X's, there are 9 pieces of yarn. So what that means is that, see this down here is length in inches, so these numbers are all different lengths of the yarn. And this one at 12 1/8 inches, there are 2 X's above it, which means there are 2 pieces of yarn that are that length. There are no pieces of yarn that are this length. There is 1 piece of yarn that is this length, 2 pieces of yarn that are 12 1/2 inches, 3 pieces of yarn that are 12 5/8 inches, 1 that's 12 3/8, and none here. Okay? So, we're still just adding and subtracting fractions. We just are going to be using line plots to represent the data. Okay? So that's the family letter. On the back page is an activity that you can do at home. So you can tear that out, show it to your family. You can do that. And then session 1 right here begins on page 463. And it's just the grossest picture ever of worms. I want to try and like cover up as much of that as I can. That's really gross. Anyway, so let's get started. It says, Emma's class has a jar of earthworms. The class measures the length of each earthworm and records the data in a line plot. What is the difference between the lengths of the shortest and the longest earthworms? Okay, and then here is the line plot. So the title is earthworm lengths, and then the number line down the bottom is different lengths in inches. Okay, so we only need to know the difference, which means subtraction, between the lengths of the shortest earthworm and the longest earthworm. Okay, so we need to look at the full line plot. The smallest length on the line plot is 4 inches, right? But there's no X above it, so there's no earthworm that was 4 inches. Same with 4 1/4, same with 4 1/2. So the shortest earthworm is this one right here at 4 3/4. Okay, so down here, I'm going to label some information. Shortest is 4 3/4 inches. Okay, and then it keeps going up in length. There's a bunch of earthworms right here. See, there's 1, 2, 3, 4, 5 different earthworms that were exactly 5 1/2 inches. That's what that means. Nothing here, keeps going. So the longest length on the line plot is 7 inches, but there's no earthworm there. So the longest one that they have, an X above, is 6 3/4. So longest, 6 3/4 inches. Okay, we don't have to worry about any of these other ones. They're just asking us what's the difference between the shortest one here and the longest one here. Okay, and since it's difference, that means we're subtracting. We need to subtract these lengths. Okay, so I'm going to put the longest earthworm in the front. 6 3/4 minus 4 3/4 equals. Okay, and then it's just the same stuff we've been doing, right? We've been subtracting mixed numbers in this past lesson, lesson 21. So I do my whole numbers first. 6 minus 4 equals 2. And then I'm going to keep my denominator the same, so it's going to be 4. But then if we look at the numerators, 3 minus 3 equals 0. So 2 and 0/4 really is just 2. Okay? So if it's 0/4, there's none left over. We can just take that part out, and it's 2 inches. Okay, so the difference between the shortest and longest earthworms is 2 inches. Okay, so that's all we're doing. That's the kind of thing we're doing this week. It looks kind of crazy at first, but the X's just mean there is something, whatever, you're talking about. In this case, it was earthworms. There is one, or, however many. Each X just represents one thing at that length, or at that measurement. It's not always going to be length, right? But then we're still just adding and subtracting. So let's turn the page and answer some questions. Okay, number 1. Explain how to find the difference between the lengths of the shortest and longest earthworms. Okay, so all we did was subtract the length from the shortest one, from the length of the longest one. So can you see that? Are you in the page? Yes. We subtracted the length of the shortest worm from the length of the longest worm. And then just to show the equation I did, it was 6 3/4 minus 4 3/4 equals 2. I'll say 2 inches. Just label my equation. Okay, so pause there if you need to catch up a little bit. Do you guys want to see something funny? Okay, pause. Where'd they go? There they are. Chickens. They're saying hi. Okay, anyway, sorry. Saw them walk by. Thought maybe you'd want to see them. Back to math. Okay. Look ahead. Number 2, a line plot is a data display that uses marks above a number line to show the number of times a data value occurs. Each data value is represented with an X. Well, that's a lot of fancy wording to say that the X means there is one thing here that is that measurement. Okay? So A, how many measurements are recorded on the line plot? Explain how you know. So how many X's are there? How many earthworms total? So all we have to do is count the X's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Hey, that's my favorite number. Thanks, earthworms. Okay, 22. Explain how you know. Well, there are 22 X's on the line plot. I counted the X's on the line plot. Cool. B, what do the 2 X's above 6 1/4 represent? So here's 6 1/4. What do those 2 X's represent? What does that mean that there are 2 X's there? That means there are 2 earthworms that are 6 1/4 inches long. There are 2 Worms, I'm just shortening earthworms to be worms. I don't think they need to know exactly what kind of worms they are. There are 2 worms that are 6 1/4 inches long. Okay. What length are the greatest number of earthworms? Okay, so we need to figure out which one of these measurements has the most X's above it, is what it's asking. Okay, there's 1, 3, 4, 5, 3, 2, 3, 1. So you can just see that bar is longest, right? I would recommend actually counting the X's though, because if you have to draw a line, you know, a line plot eventually, and you draw like giant X's and then you just draw some small ones, like that's not a great way to represent the data, right? But we're not perfect, so maybe if you do that and you're like, oh, well, that one's the tallest bar, right, of X's, so that one must be the greatest number of them. Well, no, that one has a 4, so there's more items with whatever that measurement is. So it would actually be this one. So don't always go with the tallest one. Make sure you're counting them. So what length are the greatest number of earthworms? That would be 5 1/2. 1, 2, 3, 4, 5. There are 5 earthworms that are 5 1/2 inches. Okay, so 5 1/2 inches. And explain how you know. It has the most X's above it. On the line plot. Okay, and D. Another earthworm has a length of 5 3/4 inches. Show this on the line plot. I'm going to use a different color so you can see it. They're saying we're adding in another earthworm. Okay, found another one and it is 5 3/4 inches. So you find that measurement on the line plot down here on the number line. 5 3/4 is right there. We just put a little X and try to make it the same size, about the same size as the other X's. Don't make it gigantic. Make it about the same size so that you represent it really well. And that's it. Check. Okay, number 3, reflect. If the number line is divided into fourths, why are there numbers such as 4 1/2 and 5 used to label the number line on the line plot? See, because it's going by fourths, right? 4, 4 1/4, 4 1/2, 4 3/4, 5. Okay, so think back a few lessons. 4 1/2 is equivalent to 4 2/4, right? And 5 is equivalent to 4 4/4. Okay, so they're equivalent fractions. Equivalent fractions to fourths. I think equivalent fractions was lesson 17. So if you need to think back or look back at lesson 17, it's in this workbook. It's at the beginning of this workbook. Equivalent fractions. Okay, pause on that page if you need it. Moving over to the green practice page on 465. Okay, so the first session of every lesson has this little bubble map here. In the middle is line plot. So in my own words, what is a line plot? So usually on these we just get to do like drawing. This one's at least drawings, but these ones are all going to be kind of wordy. Okay, so if you want to explain it in your own words, you can, because it is your own words, but you can also copy what I'm going to write. I'm going to write a data display. Do you guys say data or data? I feel like I use them both. I don't know. They're both right. A data display that uses marks above a number line to show number of times a data value occurs. Okay. They're kind of hard to explain, but they are easy to draw. So I'm going to do an example one. Let's say, let's just do like tree heights in my yard. I'm not obviously going to go measure my trees, but I'm just going to come up with an example, right? Tree height. So let's say 4 feet, 5 feet, 6 feet, 7. This is not a good example because these are not fractions. Oh well. 8, 9. Okay. And then you label the bottom, length in feet. Okay, usually in parentheses you write like, is it feet, is it inches, is it centimeters? You know, what unit are you measuring in? Okay, let's say I have 1 at 4 feet, 2 at 5 feet, none at 6 feet, 3 7 feet tall trees, 2, 3, 4, and 1. Okay, so I'm just making up data. I don't actually know the heights of my trees. But whatever you want to do there, you can copy my example if you'd like. You can make up your own. But there are certain things that we cannot measure with a line plot, which is the non-examples. Okay, so first we'll do some examples, and it's just going to be a list. We're not drawing different line plots, okay? So what are things that you can show with a line plot? I could show height of my friends. I could show that in a line plot. I could show lengths of my pencils in my classroom. Some of them are like this big somehow. You guys are crazy. Lengths of pencils. Or lengths of snakes at the zoo. Okay, so they're measurements, right? Heights, lengths. There are things that I could put down here as measurements and then count how many are that height or that length or weight, whatever, right? Okay, so what about non-examples? What are things that I can't show with a line plot? I can't show the sports I play. A line plot would not be a good way to show that data. Okay, I could make a list of the sports I could play, but not a line plot of it, right? That'd be weird. It'd be like football, track, softball, baseball, basketball, volleyball. It's like just one X above, like it doesn't make sense, right? You can't do that. How about the number of friends I have? Number of friends I have. You can't show that with a line plot. Okay, because it's like, well, I have 2 friends. Great. How do I put that in a line plot, you know? If I was going around my classroom and I was asking everyone how many friends you have, then it could be like 4 friends, 5 friends, 6 friends, and it'd be like, okay, well, 1 person has 4 friends, 2 people have 5 friends, nobody has 6 friends, 3 people have 7 friends. But it can't just be myself. I can't just show the number of friends I have, okay? Or favorite ice cream flavors. Okay, that doesn't belong on a number line. Okay, so there are certain things that you can measure with a line plot, and then there are a lot of things you cannot measure with a line plot. That could go on forever. Okay, let's go down to number 2. All right, number 2. Use the line plot to answer the questions. What length are the greatest number of ribbons? Explain. So, which measurement down below, so these are all ribbons, each X represents a ribbon of that size, which length has the most X's above it? It would be 7 inches. There's 1, 2, 3, 4 ribbons that are all 7 inches. Okay, so it's not asking what's the greatest length, because that would be over here at 9. They're just asking what length are the greatest number of ribbons. So which number on here is greatest? Well, that would be 4 ribbons at 7 inches. 7 inches. Explain. It has the most X's. Okay. Suppose there's another ribbon that is 9.5 inches. Show this on the number line. Okay, so at 9.5, right here, show another ribbon. I'm going to add one more. Okay, my little red X. Did a different color so you could see it. Okay, so you just put an X above 9.5. Check. Done. Then the back page. Okay. Good. Good enough. Number 3. Solve the problem, show your work. Marlon measures the height of each flower in a vase. He records the data in a line plot. What is the difference between the heights of the shortest and tallest flowers? Okay, so that's what we did in the example problem with the worms, right? What's the difference between the heights of the shortest and tallest? So same thing as the difference between the lengths of the longest and shortest worms. So down here it's 5 inches, and then it goes all the way up to 8 inches for flower heights. So the shortest one, there's nothing above 5, so the shortest flowers are these two that are both 5 1/4 inches. The tallest height on the line plot is 8 inches, but there's nothing here, or here, or here, or here. Oh, wait, there's one there. I got ahead of myself. Okay, so that's the tallest flower, that one, and it's 7 1/4 inches. So to do the difference, we need to subtract those two. Okay, so I'm going to take 7 1/4 minus 5 1/4. Okay, so whole numbers first. 7 minus 5 equals 2. Denominator stays the same. Numerators, 1 minus 1 is 0. 0/4 means nothing. My answer is 2 inches. Isn't that the same as what it was before in the worms? It was. Weird. Okay, so the difference between the heights of the shortest and tallest flowers is 2 inches. Okay, and then number 4 down at the bottom, check your answer, show your work. So how would you check that? I would say we did it already right here, but we could add 2 to 5 1/4 to see if we end up at 7 1/4. So 5 1/4 plus 2 equals, whole numbers first, 5 plus 2 equals 7, 1/4 plus nothing equals 1/4. Check. Ta-da! And that's it for session 1. See you guys in the next video for session 2.